us. We'll be alone together here on the internet.
And I love what you said, because even from the screen you can see the DSS-25 from Goldstone is actually tracking M20, meaning us, Perseverance.
Ah, very nice, very nice. Right now the one-way light time between Earth and Mars is about 11 minutes. It'll be 11 minutes 22 seconds if I remember my press kit on landing day. So we'll be broadcasting live from this room, and we'll get to a little bit more about that at the end of our show, how you can tune in live and be part of that action. But before we get to that, Deanna, the dark room here is not the only thing in this room we should call out.
Exactly. So, okay, so this is really cool, but then to the left, you will see the room where entry, descent, and landing will be happening. So all the team members from operations that will be sitting on station is on the left side, where you can see the bottom of the American flag. You can even see the flight director and the EDL, entry, descent, and landing, activity lead signs. So whenever you see the broadcast, you're going to be watching that room live.
Okay, so let's go ahead and go to some questions from the internet here for Deanna.
Sure.
Danielle asks, what's the difference between entry, descent, and landing on Perseverance compared to Curiosity?
Oh, good question. Okay, so one of the differences that is very important is the way that Curiosity came in. You know, we did the whole navigation, it finds where we have to actually land, but the difference with Perseverance is that this go around we're going to do it with eyes open. That's how we describe it, which is it's actually taking images as it's coming in and then comparing it with an onboard map to determine exactly how to navigate to safely get to the place that we're going to land. So yeah, that's a key difference.
All right, so Emma Harding, tuning in from the UK, is there with her 9-year-old son Oliver, who is super excited for the mission. He wants to know, how long did it take to build the Perseverance rover, and how many people did it take to build it?
Oh, that's a great question. So it takes a lot of time. It takes approximately from the beginning of conception of like saying what's the design looking like to the point where we actually put it on the rocket. It's approximately 10 years or something along those lines. And it's a ton of people. It's a ton of people. In even not so many people, it's also people from different countries, from different languages. It's very great because you come in together as an international group and an international team to build this thing.
And once we're on the surface, Daniel Ryan on Facebook asks, how long is the mission?
How long is the mission? So the mission itself has 2 different stages. The actual primary mission, it will be a 2 Earth year, 1 Mars year on the surface of Mars. And so we hope that we can answer the question and the objective is by that time. But usually the missions then eventually get extended because we're still on the surface of Mars. And in this specific case, we have nuclear power, so we can stay longer. But the primary mission is 1 Mars year.
All right, so we're going to get all that seasonal data that the scientists are so hungry for. And Moxie, too. Moxie needs to see how it behaves over all the seasons. Okay, Christopher Mick on Facebook asks, how much of an orbit does Perseverance make of Mars before starting entry, descent, and landing?
Oh, how much of an orbit? That's a good question. So we're coming in straight into Mars. We do TCMs to correct exactly where we're going to do the entry point. But once we hit the entry point, we're just going straight in through the atmosphere to land. So there's not much time that we're wasting. As soon as we feel the atmosphere, we're just going in.
And on the software side of things, Noor the Door asks, how complicated is the automated landing sequence, and who wrote the code?
Ooh, that's a really interesting question. Okay, so very complicated. I think the way that I describe it is we're touching the top of the atmosphere of Mars at 20,000 kilometers per hour, which is insanely fast. And then the complicated aspect of it is that it has multi-parts that come off at the specific instances while taking pictures and having retro rockets and landing. So you can imagine that just my description is super complicated. So now, I will say we tested constantly, we tested multiple times, and the code itself is actually a team. So it's a team of people that write different pieces of that area, the devices that are going to be used, how those devices are going to get integrated, and then the software itself, it gets built by lots of different people that we get to test with lots of different more people.
Okay, you touched on this a little bit with the needing to see the surface to choose that landing site. So Nancy Wilkins wants to know, is it the rover Perseverance or the descent module taking those images to find the safest landing site?
The safest landing site. That's a really good question. So when the back shield of the rover comes, so it has a heat shield and it has a back shield. When the heat shield comes out, there is a radar that we point down to find actually the location of where we're going. So it is not per se the actual rover itself, it is actually the descent stage that has the radar, the LiDAR that will find the location. But there's one thing that I like about your question, which is the rover itself on a side also has a camera that will be taking pictures as it's coming down. So we got two imagers giving us information.
All right, Avina's HJ98. Can I be a member of this mission? How can I work for NASA?
Oh my goodness, of course you can be a member of this mission. It takes everybody to get to do this, right? Like the questions are things that we have never asked ourselves before, things that we have never tried before. So we kind of need everybody to come up with their own way of seeing things from their different angles. So I will say go to nasa.gov, check out JPL for any openings that there is. And if you are not interested in those jobs, you can certainly follow the show and be part of all of this, even with the online activities that Stephanie and her team have.
All right, that is a perfect segue. If you want to know how to participate in the mission, if you want to join our Mission to Mars Student Challenge, if you want to join the conversation with the rover on Twitter and Facebook, all of that you can find at go.nasa.gov/Mars 2020 Toolkit. And oh my goodness, here it is, it's Tuesday afternoon, Thursday. We're going to be live streaming from this room. We'll be live streaming in 2D, in 360 degrees, and for the first time ever, en español.
En español, yes, for the first time ever, vamos a tener un show en español del aterrizaje de Perseverance. Empieza a las 11:30 Pacífico, 2:30 Este. Así que si nos quieres ver en YouTube es NASA-ES. Nos vemos ahí.
So this is NASA. We got space for everyone. We hope that you will join us. We'll see you online. Hashtag Countdown to Mars.
You know, Mars is the closest place that we can reach with robotic exploration that we think had a really good chance of having ancient life.
The Perseverance rover will land at a location called Jezero Crater. Jezero Crater is a very interesting place. It's a crater that once held a lake.
There are a lot of craters on the surface of Mars that could have once hosted ancient lakes, but not every crater that we think had a lake actually preserves evidence that that lake was there.
It had an inflow channel and it had an outflow channel. That means it was filled. The crater was filled with water.
In Jezero, we have probably one of the most beautifully preserved delta deposits on Mars in that crater.
This is a wonderful place to live for microorganisms, and it is also a wonderful place for those microorganisms to be preserved so that we can find them now so many billions of years later.
There is no other place on Mars that has the unique combination of a lake setting, a beautifully preserved delta, and the diverse mineralogy that we have in Jezero Crater. So it's truly a special landing site.
The major goal of the Perseverance mission is to investigate astrobiology on Mars, and in particular, to address the question of whether life ever existed on Mars. The Perseverance rover starts with a design that's very similar to Curiosity, but we've added to it a whole new set of science instruments. And these science instruments were purposefully selected to help us in the search for biosignatures.
We're going to be taking microphones with us. For the first time, we're going to have that human sense on another planet.
Perseverance carries with her a grand experiment in spacefaring technology, a helicopter, the name of which is now Ingenuity.
One of the major upgrades that Perseverance has from Curiosity is that it's able to self-drive for a distance of up to 200 meters per day. As the rover is driving, it's literally building the map of the road it's driving on Mars.
Scientists for years have told us that to really unlock the secrets of Mars, we have to bring samples from Mars back to Earth.
So what Mars 2020 is going to do is to drill samples, put them in small tubes. We're going to seal it in its own individual tube. We set them on the surface to provide a target for the second two missions, which hopefully will get in development in the next several years and could potentially get the samples back to Earth by 2031.
Perseverance is a very, very profound first step in both our understanding of our place in the universe and a stepping stone towards human exploration on Mars.
Nothing can be taken for granted when you get to Mars. There's a lot of things we just don't know.
Space always has a way of throwing us curveballs and surprising us.
I mean, until we get the data that says we're on the ground safely, I'm going to be worried that we're not going to make it.
Entry, descent, and landing is often referred to as the 7 minutes of terror because it takes about 7 minutes to get from the top of the atmosphere of Mars to the ground safely.
The spacecraft has to do all of this by itself.
There are many things that have to go right to get Perseverance onto the ground safely.
There's a lot counting on this. This is the first leg of our sample return relay race. There's a lot of work on the line.
Starting about 10 minutes before atmospheric entry, we get rid of really the spacecraft part of the rover that's been supporting us.
We come screaming in to the Martian atmosphere at 12 to 13,000 miles per hour.
And the heat shield is what dissipates all that initial energy through friction.
The vehicle will continue actually flying itself through the atmosphere. It's sort of like a transforming vehicle that went from spacecraft and now it's kind of like an aircraft actively guiding itself.
When we're going slow enough, we deploy a parachute.
The biggest supersonic parachute we've ever sent to another planet. It's critical for slowing down the vehicle.
Perseverance's entry, descent, and landing borrows heavily from that of Curiosity.
But fundamentally, Perseverance is a different rover. She's bigger, she has different instruments.
We've added a lot of smarts on the inside to make it more capable so that it can deal with the landing site that we've given.
The science team identified Jezero Crater as basically an ancient lake bed and one of the most promising places to look for evidence of ancient microbial life and to collect samples for future return to Earth. The problem is it's a much more hazardous place to land.
You look at Jezero, all you see is danger. how do we go to a site that we never thought was safe enough to go to before? So the heat shield, which has protected us all the way through entry, is no longer necessary. We need to get that off so that we can actually see the ground. And we can see the ground in a couple different ways.
Perseverance will be the first mission to use terrain relative navigation. So while it's descending on the parachute, it will actually be taking images of the surface of Mars and determining where to go based on what it sees. This is finally like landing with your eyes open. Having this new technology really allows Perseverance to land in much more challenging terrain than Curiosity or any previous Mars mission could. Amongst the rocks and the craters and the cliffs, these things are hazardous to the rover, but these are the things that are interesting to the scientists.
Once Perseverance has figured out where she is, jettison the back shell and parachute, and light up our rockets. Those rockets help us steer to a safe landing spot that's nearby.
That descent stage takes us all the way down to about 20 meters off the ground.
That's when we start the sky crane maneuver. Once the rover has hit the ground, the descent stage will cut loose from the rover and fly away to a safe distance. Surviving that 7 minutes is really just the beginning for Perseverance. Its job, right, being the first leg of sample return, to go look for those signs of past life on Mars. All that can't start until we get Perseverance safely to the ground. And then that's when the real mission begins.
The terrain in Death Valley is very much like Mars. It has a lot of sand dunes and steep slopes. It's quite similar to the landing site that Mars 2020 will be going to. We're taking a copy of the system that will be on the spacecraft, and we're testing it in the way that it would be used during the flight mission.
Terrain relative navigation gives the vehicle the ability to figure out where it is. This is kind of along the same lines of what the Apollo astronauts did with people in the loop back in the day. Those guys were looking out the window and looking for different craters and other features on the moon that they knew of from the maps we had of the moon. So that way they could figure out where they are and figure out where they needed to land to be safe. So for the first time here on Mars, we're automating that.
What terrain relative navigation gives you is the ability to avoid hazards that you already know about. So large hazards, hills, craters, things that you've seen before. With the camera, we take images as we're descending, and we match pieces of the image to orbital imagery that we have stored on board. And if we make many of these matches, we're able to figure out where we are relative to the map.
If we didn't have terrain relative navigation, the probability of landing safely at Jezero Crater is about 80 to 85%. But with Mars 2020, we can actually bring that probability of success of landing safely at Jezero Crater all the way up to 99% safe every single time.
We don't have an astronaut that we can put on board Mars, but we can put this system, this terrain relative navigation system, so that the spacecraft could figure it out on its own.
I could see it being used on lunar missions, science missions, as well as human missions. Future Mars missions, of course, Mars sample return, Europa lander, landing on a comet, pretty much everywhere you want to land. You're going to want to have terrain relative navigation.